Hello students, I am Dr. S.M. Bhatti. The objective of this video is to solve some examples on moments, skewness and kurtosis. Here is a first example. If the first four moments of a distribution about 5 are -4, 22, -1, 17 and 560. Determine central moment beta 1 and beta 2. Now we are given the first four moment about 5. But what is 5? Whether 5 is mean, that is not mentioned. That means this 5 is taken as a capital A. In other words, we are given the first four moment of distribution about 5 as a -4, 22, -117 and 560. So these are the values of mu r dashes. That means mu1 dash is actually -4 and this mu2 dash is here 22, mu3 dash is a -117 and mu4 dash is here 560. So you have to understand these values, that is mu1 dash, mu2 dash, mu3 dash and mu4 dash. These values are given in the problem. Now we know that mu1 dash is 1 upon n summation f into x minus a. A is 5, as I said you, a is 5. Fine. So this became 1 upon n summation fx minus 5. That means x bar minus 5. Right? So here mean is x bar and that is equal to mu1 dash plus 5. That means -5 plus 5, that became 1. So we have a mean as a 1 here. Now we have obtained the value of mu. Let's find now a value of mu2. Okay, because mu1 is always 0, no doubt. We don't require any calculations. Mu1 is always 0. Now we have to find mu2. And we have formula mu2 is equal to mu2 dash minus mu1 dash whole square. Now put the value of mu2 dash and mu1 dash in this equation. We will find mu2 and we find mu2 is here 6. Then mu3 we have this formula, and in this formula we put the value of mu3 dash, we put the value of mu2 dash, we put the value of mu1 dash, and when we simplify we will find the mu3 is equal to 90. Now finally we have to find mu4. Again we have a formula for mu4 like this. You need to remember this formula and put the values, put the known values in right hand side. That is, put the value of mu1 dash, mu2 dash, mu3 dash, mu4 dash, and when you make a simplification you will find mu4 is 32. So in this way we have obtained the value of mu2 as a 6, mu3 as a 19 and mu4 as this 32. That and these and mu1 is always 0. That means we have obtained the value of mu1, mu2, mu3 and mu4, and which are nothing but moment about the mean x bar. And these are also called as central moment. So central moments are nothing but moment about x bar, and we obtain them mu1 as a 0, mu2 as a 6, mu3 as a 19, mu4 we obtain and then it is a 32. Now we have to obtain the value of beta 1 and beta. Coefficient of skewness is nothing but beta 1. It has a formula mu3 whole square upon mu2 whole cube is equal to, we put the value of mu3 here, mu3 is 19, take whole square upon mu2 is 6, take cube here, and when you simplify this we can get the value, it is 1.6773. Now kurtosis is given by B2 and which has a formula mu4 upon mu2 whole square. Now mu4 is 32 and mu2 is 6, so 6 square will be the denominator, and when you simplify you will find it is a 0.8889. Because B2 is less than actually 3, so the distribution is a platycurve. So curve is a flattened curve, then the normal curve. Now we'll take the second example. So here is second example. Calculate first 4 moment about mean of the given distribution. Also find skewness beta 1 and kurtosis beta 2. So we are given this table. So first you have to understand this table. This table is a frequency distribution table. It is a discrete frequency distribution table. The 2 has a frequency 4, 2.5 has a frequency 36, 3 has a frequency 60, 3.5 has a frequency 90, and so on, right? So we take A as a assumed mean. So we take A as a 3.5, right? We take A as a 3.5 and we have formula U equal to x minus A upon h. So x we keep as it is. A, that is we have taken 3.5 and h stand for the width of the class, width or difference between the x size here. Here first x is a 2, next is 2.5 and here 3, then here 3.5, 4, then 4.5. That means value of x are equally spaced and spacing is here h and that h is here 0.5. And now we have to prepare the table which help you to calculate mu1 dash, mu2 dash, mu3 dash, mu4 dash and finally beta 1 and beta 2. Now this kind of table we need. Here first column represent x and x are here 2, 2.5, 3, 3.5 and so on. Next column is for f. The f means here frequency. And if we add all the values of f, you will find here 310. So 310 represents summation f, that is the total frequency and it is nothing but capital N. So capital N is equal to total frequency, that is summation f, means we have to add this second column and here column sum is 310. Then now for each x we have to calculate u and we have formula for u. As we have seen just now, for this particular example, u equal to x minus a upon h. A is a 3.5 and h that is a spacing of the x values. It is a 0.5. So using this formula, we have to modify x to u. So we have modified the x to u. For example, when you take x is a 2 here, so 2 minus 2.5 upon 0.5, that became minus 3. When x is a 2.5, you find 2.5 minus 3.5 upon 0.5, that became minus 2. And if you take x is 3.5, so you can see 3.5 minus 3.5 upon 0.5, that became 0 and so on. Once you develop this column u, you have to multiply f and u. So if you multiply the respective f column and u column, if you multiply respective numbers, 4 into minus 3 is minus 12, 36 into minus 2 is minus 72 and so on, we get this next column. And if you column sum for this column is 36 and which represent summation fu. Next you have to develop fu square. Now from u, you have to understand u square. So u square column will be 9, 4, 1, 0, 1, 4, 9. This will be u square column and you have to multiply u square column with f. You will find this column. From u, you can calculate u cube and multiply u cube with frequency. You can develop this column. Finally, from u, you calculate u raised to 4 and multiply that column with the frequency. You can get next column, that is fu square, and each time we have to get the columns. So if you add these entries, these 1, 2, 3, 4, 5, 6, 7. So if you add these 7 entries here, you find this column sum and this represents summation fu square. Again, if you add these 7 entries here, that will give you 204. It is a column sum, and similarly adding the column sum for the last column represents summation fu raised to 4. Now we have to use column sums obtained in the table to find the values of mu r dash. We know formula of mu r dash. Mu r dash is h raised to r summation fu raised to r upon summation f. That is h raised to r upon n summation f u raised to r. So here if you put r is 1 here, you can get the formula of mu1 dash. Mu1 dash became h upon n summation fu. Now h is a 0.5. N means summation f, it is a 310. The summation fu, it is a 36 obtained in the previous table. Fine, we have put these values and we can get the value of mu1 dash. Now mu2 dash, has the formula. How to get the formula for mu2 dash? Put here r is a 2. So if you put r is 2 here, you will find mu2 dash is equal to h square upon n summation fu square. H square means 0.5 whole square, n is a 310, and summation fu square is obtained, can be obtained from the table. It is 560. When you simplify this, you can get the mu2 dash. Similarly, you can write the formula for mu3 dash. This is a formula for mu3 dash. Put the known values in right hand side and obtain the value of mu3 dash. Similarly, if you put here r is a 4, you can write the formula of mu4 dash, and now put the known value in right hand side. Simplify, you will find it is a 0.5. So in this way, you obtain the value of mu1 dash, mu2 dash, mu3 dash, mu4 dash. These are the moments about A, that is moment about 3.5. These are the moment about 3.5. Now we have to find moment about the mean, and for that purpose we have to take help of these values of mu1 dash, mu2 dash, mu3 dash and mu4 dash. We know that mu1 is always 0, so we don't need any calculation. That we can write mu1 is 0. Now this is the equation which represent the value of mu2 in terms of mu1 dash and mu2 dash. Now just we obtain the value of mu1 dash and mu2 dash. So in this equation, in the right hand side, put the values, put the value of mu2. You can see the mu2 dash is 0.451612, minus sign is here for second term. Then mu1 dash whole square. So put the value of mu1 dash here, it is 0.058064 whole square. When you simplify this, you can get the value of mu2. Then look at this formula, already we have seen. So this formula represents the value of mu3 in terms of mu1 dash, mu2 dash and mu3 dash. So put the value of mu1 dash, mu2 dash and mu3 dash in the right hand side here. Simplify this, we can get the value of mu3. So we obtain here the value of mu3. Then this is a formula for mu4. You can see left hand side we have mu4 and right hand side we have expression in terms of mu1 dash, mu2 dash, mu3 dash and mu4 dash. Simply now put the value of mu1 dash, mu2 dash, mu3 dash and mu4 dash obtained in the previous steps and make the calculation very carefully. You can get the value of mu4. So in this way we obtain the value of mu4, mu3, then mu2 and mu1. And you know mu1, mu2, mu3 and mu4 represents moment about the mean, and we are asked to find moment about the mean, and now we obtain the moment about the mean using moment about 3.5. Now coefficient of skewness is given by beta 1 and it has a formula mu3 square upon mu2 cube. So put the value, simplify, you can calculate the value of beta 1. So beta 1 represents coefficient of skewness. Then let's find kurtosis. It is a beta 2 and beta 2 has a formula mu4 upon mu2 whole square. Put the value of mu4, put the value of mu2, take a square, simplify, we can get the value of beta 2. You can see that beta 2 is less than actually 3 and hence the distribution is plateauchotic. These are the two references that we have used while taking the problems on moment, skewness and kurtosis. In this way, we have seen how to find moment, skewness and kurtosis for the some problems. Thank you very much for watching this video completely.